Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for checking whether the given two trees are same. Let's look at the problem description. We are given roots of two binary trees and we have to check whether both the binary trees are same. The binary trees are considered same if they are structurally identical and the nodes have the same value. Let's take a look at the example 1. So we are given two trees with 1, 2 and 3 and 1, 2 and 3. In this case, structurally both are same and the values are also equal. These two trees are same, so we return true. In this case, both have the same set of values, but the first tree, the 2 is present on the left child, and in the second tree, the 2 is present on the right side. So structurally both are not same, so we have to return false. So number of nodes in both the trees will be ranging from 0 to 100, and the values will be minus 10,000 to 10,000. We are given two trees which have elements 1, 2, 3 and 4. Both the trees are structurally as well as the value is same, so we have to return true. So the approach is we have to perform a pre-order traversal on these two trees at the same time and then check whether at each recursive call we have to check the current nodes are same. If not, we have to return false. If it is true, then we make a call recursively to check whether the left subtree of both the nodes are same. So we go recursively all the way to the leaf and then build the final result as we come back. Basically, we compute the result bottom up way. Okay. So whenever the left and right child returns their result, we have to compare, and if both the results are true, only then we have to return true from the parent's node back to its parent. Let's look at the flowchart. Input for this procedure is the root pointer to the root node of both the trees P and Q. First we initialize the return value to true, and next we check if both P and Q both are null. Then we simply return the retval as true. Otherwise, we check if either one of them is true. That means both the trees are not same. So we have to update the return value to false and then return it. If not, if both are not null, then we have to check whether the value of both the nodes are same. If not, then we have to update the return value to false and return it back to its parent. Otherwise, if we just make a recursive call to process the left subtree of the current node P and Q, and if that left subtree is same, then the return value of that call will be assigned to the variable left. Same way, we make a recursive call to process the right subtree of node P and Q and assign the return value to the variable right. Once we get the result from the left and right subtree calls, then we have to check if both are true. In that case, we can declare the tree is same. Otherwise, we have to update the return value to false and return the retval back to the caller. Let's move on to coding. First, I initialize the return value variable to true, and then I check whether the root nodes of both the trees are null. If so, I return true because both are empty trees, both are equal, so we return true there. But if any one of them is not null and one of them is null, then we have to return false. So I update the return value to false because they are structurally not same now. Then I check the value of both the nodes are equal. If they are not equal, then that also we can conclude they are not same, that both the trees are not same, so I return false. And then we have to make a recursive call to process the left child of both the root nodes. So we are passing the left child of the current root P and current root Q. Then assign the return value to the left variable and then make a call to process the right child of both the roots. Once they return the value, so when they return, we have to check whether both the left and right are true. In that case, we have to return true, otherwise we have to return false. Next, I am going to run the test cases. Okay, all the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. So we are given two trees with values with the nodes 1, 2, 3 and 4, and structurally as well as the value wise both are same, so we have to return true. Let's see how we can get the value true. Okay, so first we call the same tree function. In the first call, the root nodes P and Q are passed to this function and we check whether both are null. Now they are not, and then we check whether either one of them is null. That is also not true. So then we come to this condition, we check whether both the values are not same, but here both are same. So we go ahead and try to process the left subtree of both the nodes. So in the case of P, the left subtree this, in the case of tree Q, the left subtree is this. So we make a recursive call is same tree. So the stack frame 1 is created, and there first we initialize the return value to true and we check whether P and Q are nil, both are not nil, and then we check either one of them is nil, that is also false. Then we check whether the value of the current P and Q are equal or not equal, so that is also of false. So we go ahead and process the next their left side. So we are coming here, the stack frame 2 is created. In this case, first we check whether both P and Q are nil, they are not, and then either one of them is nil, that is also not true. Then we check whether both the values are not equal, that is also false. So we go ahead and try to process the left subtree of this node and the left subtree of this node, so which is null. Okay, and we make a call here and we check P is nil and Q is nil, that is true. So the return value true will be returned back to its parents, and that is assigned to the left variable. Same way the right also, right subtree of this node which is also nil and right subtree of this node is also nil. So we make another recursive call and in that case it will return true. So finally the left and right return values are checked whether both are true. In this case, yes, it is. So this node will return the value true back to its parent. So once we go back to this Then we check, we make a call to the right subtree of both the nodes, which is nil. So we get the true as the return value, and it will propagate it back to its parent as true. Then once the left subtree of that the root p and q are processed, then we come to the right subtree. So in this case only one node is there. So when we come down, we check both are nil, they are not, and either one of them is nil, that is also false. Then we check whether they are not equal, but in this case they are equal, so we proceed and try to make a recursive call to process their left and right. As we know, when we process the node 4, we know when we call the nil subtree, we get the true uh, as a return value. So in this case we get true, and which will be sent back to the parent, and the parent node will check whether the return value returned by this subtree and this are true. In this case both are true, so finally we return the value true back to the caller. Next I am going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. We have two trees. So in this, in order to determine whether both are same or not, we have to traverse all the nodes in that tree. So the number of nodes in this case is 4. So we have to make a recursive call 4 times. So the time complexity for this solution is order of n. And with respect to the space complexity, we do not allocate any additional space, but internally we use the stack space. At any point, the maximum number of stack frame we need is log n base 2, which is the height of the tree. So in this case, log n 4 base 2 is 2. So the space complexity for this solution is order of log n. Thanks for watching this video. Have a great day.